Okay, this video is going to be dealing with complex numbers. Another name for the word complex is what we call imaginary. So imaginary numbers. And a way we represent imaginary numbers is this variable I. Okay, so it is a lowercase I, it looks italicized. That's how we represent imaginary numbers. So whenever you see an I in a problem, you know that we're dealing with complex values. Before we get into some examples, we need to go through some background. So complex numbers are numbers that are not real. Okay, I can't see them on an XY coordinate plane. I can't graph them. I can't do any of that stuff. Basically, they're just there because they represent something that doesn't actually happen in real life. So what happens is I actually stands for the square root of -1. The reason why we use a variable to represent the square root of -1 is, if we remember anything from square roots are numbers times itself, give me the number that's inside. So 3 times 3 would be 9, so the square root of 9 is 3. But I can't multiply a number by itself and get a negative number. That's not ever going to happen. So -1 underneath the square root doesn't exist. So we represent it with an I because we still have to account for it. So because I is square root of -1, if I were to take I and square it, so if I took I and squared it, and if I took square root of -1 and squared it, then I would just get -1. So anytime you have an I squared, that I squared is -1. That's besides what the other values are. So just I squared is always is -1. Okay, so going further, I to the third power is just negative square root of -1, which is also -I. They're both, all those things equal each other, just different ways to write them. And then I to the fourth power is +1, because that I'm taking this and I'm squaring this. So 2 times 2 is 4, and then any number squared is just the positive number of what it is. So -1 times -1 is just +1. So that's a little background. So I squared. So let me erase this here, and I will write it a little nice without all that extra stuff there. So we can put that in our notes if we need it. So I equals square root of -1. I squared equals -1. I to the third is equal to negative square root of -1, or just -I. And then I to the fourth power is equal to +1. So those are your 4 different levels of i's. Every number, every exponent you have is either one of those. Okay, so for instance, I to the 100th power is 1. I to the 1000th power is 1. And you can figure that out all the way through. Again, complex numbers, we talked about i's and all that stuff. Well, complex numbers are written in a way that you have a plus bi. So this is your imaginary part. And this a here is your real part. Remember, real part means this is a number that we can actually graph, okay? So that's a number -1 or +7 or 15. We can graph that number. It exists on a number line. Whereas imaginary part, the i's don't exist on a number line, so that's why it's the imaginary part. You'll notice it's a plus bi. So every time that we're doing one of these problems, I need to write it that way. I need to have my i's at the very end, my real part at the very beginning. If I mix them up, that's not good. That's not the proper way complex numbers are written. Okay, a plus bi. Now let's get into some examples and hopefully learn a little bit more about complex numbers and how they react to certain things. So this example on the board, if you notice, I have a complex number here and a complex number here, and in between them I'm adding them. So how do I go about doing this? They act as though they're regular numbers, regular i's and all that stuff. This is a 1 right in front of that parentheses. So what happens is I have to distribute, okay? So this is technically a 1 here, but 1 times all that just stays the exact same as what it was inside. Well, now I'm multiplying the 1 times the second set of parentheses, and I get minus 2 plus 8i. Again, 1 times negative 2 is negative 2, 1 times 8i is 8i. Now, just like you did when you were simplifying expressions with like combining like terms, things like that, the i's go together. And the numbers that are not i's, the real numbers, go together. So I can combine like terms. So that makes negative 5, and then 3 plus 8i is 11i. And that is your solution for this particular example. Next example. You notice I have 3 sets of parentheses. That doesn't matter. Again, 1 times all of that is just what's inside. 1 times all of that is just what's inside. 1 times all of that is just what's inside. Now I have more than a couple terms like I did in the last one. I have more than that, right? So now I have to combine like terms again. 4 and negative 1 and negative 3 can go together. 4i, 3i, negative I go together. 4 minus 1 is 3, minus 3 is 0. 4 plus 3 is 7i, minus I is 6i. Now, you notice that there's a 0 in front of my 6i. Well, yeah, well that's 0 plus 6i is just 6i. That is how we write this one because the 0 doesn't matter. If I add 0 to anything, I just still get that anything, right? So our answer is 6i. If you write the 0 in there, you're not fully simplified. It doesn't say simplify part ways. It says simplify. That means do it all. Okay, so here's this example. This will be the last one we do for this video. Again, I want to now subtract them all. So again, I have a 1 out here. 1 times all of that is just negative 7 plus 6i. I now have a negative 1 times that parentheses, which makes it a negative 2 minus 5i. See what happens? That the negative 1 flips the signs. That's what a negative 1 truly does. This is also a negative 1 multiplied. That gives me a positive 7 minus 5i. Again, you see that there's a negative 1. It flips the signs of what's inside. So now I combine like terms. Negative 7 minus 2 is negative 9, plus 7 is negative 2. 6i minus 5i is 1i, minus 5i is negative 4i. And that concludes this video. If you need help with multiplying complex numbers, then please tune in to the next one.